Hello everybody. Welcome to another video on some of the frequently asked questions I get as I work with students in mathematics. Today we're going to talk about composition of functions part 2. In part 1 we talked about the basic operation of composition, and in this video we're going to go a little deeper and talk about rational functions and their composition, as well as radical functions and their composition, and we're going to look at the domain of each. Now, by the way, if these videos are helping you, please press like and subscribe, and we'll get right into it. Okay, we want to find today f of g of x, the composition f of g of x. I'm going to write the notation like this to make it more plain what we mean when we say f of g of x. We're going to take the function named g of x and insert it in place of x in the function named f of x. It looks like this. Wherever I see an x in f of x, I'm going to put a little gap. And into that gap, I'm going to insert the function named g of x. So we put 3 over x here and 3 over x here. Now that's the composition. All I need to do now is to simplify it. So I'm going to multiply by a clever form of 1 in order to simplify this complex fraction. When I multiply the numerator by x, the x's will cancel. Do you see that? And I end up with just 3. And when I multiply the denominator by x, well, I'm going to have to distribute here. And I get the x's canceling again here. And then x times 1 is just x. So that's the composite function f of g of x. Now I need to talk about the domain. When you find the domain of a composite function, you need to consider the inside function, in this case 3 over x, and the composite. You do not consider the outside function because the variables in the outside function are going to be replaced by the inside function. So let's look at both of those, the inside and the composite. The domain of 3 over x, well, we need to exclude all the values that make the denominator 0. And in this case, that would be 0. So x cannot equal 0 for the inside function. Now for this function, what value would make the denominator 0? Well, x could not be negative 3. That would make the denominator 0. So then the domain of the composite function f of g of x would have to exclude both 0 and negative 3. So we write the domain is all x values such that x cannot be negative 3 and x cannot be 0. Okay? Our second example will be one involving a radical function. G of x here is the square root of 4 minus x squared. We're going to find f of g of x, g of f of x, and their domains. So here's f of g of x. Remember, I like to write the notation like this to make it clear. So we find the function named f of x. We leave a gap for g of x, and we insert that function, the square root of 4 minus x squared, into the gap. So let me just drop the parentheses here. There is the composition f of g of x. Now we want to find the domain of this function. Remember that when you find the domain of a composite function, you need to consider the inside function and the resulting composite function. You do not need to consider the outside function because the variables in it will be replaced with the inside function. Okay, so let's first look at this inside function. It is a square root, and underneath the square root is 4 minus x squared. That's the same one, coincidentally, that's the expression under the root here. So the domains here will be the same. Remember, up under a square root, you should not have a negative number if you want a real number answer. So I'm going to go over here and do a little work to make sure that what is up under the root sign will be non-negative. So here's my little work. I'm going to solve this inequality. I'll move the x squared to the right hand side, and let me just switch the order to make it more conventional looking. Okay, we need to take the square root of x squared to get rid of that, square root on both sides. The square root of x squared is defined to be the absolute value of x. So the absolute value of x would be smaller than 2. And so x would be between 2 and negative 2 inclusive, including, that is, negative 2 and 2. So that is the restriction on x, and that is the domain of this function. So the domain of f of g of x is all x such that x is between negative 2 and 2 inclusive. Now let's find g of f of x in its domain. G of f of x has f as the inside function. So we're going to find the function named g, and we're going to leave a gap where the x is. Inside that x, we're going to put the function named f of x. There it is. Simplifying, we have 4 minus 4x squared. So again, to find the domain, we need to consider the inside function, in this case f of x, and the composite function. F of x is a polynomial function, so its domain will be all real numbers. The domain of this composite function will have to have values so that there is no negative number, again, under the square root. So I'm going to go over here and do my work. That expression must be non-negative, greater than or equal to 0. I'm going to solve for x by, let me move the 4x squared to the right-hand side and then change the order, I guess, to make things look more conventional. I'm going to divide both sides by 4, and I get x squared is less than or equal to 1. Now again, to get x by itself, we need to take the square root of both sides. The square root of x squared is defined to be the absolute value of x, and that must be smaller than 1. So then, x must be between negative 1 and 1 inclusive. So since there was no restriction on x in the function named f, our domain will be this restriction. So the domain of g of f of x is all the values of x such that x is between negative 1 and 1 inclusive. Okay, thanks for watching, and I'll see you next time.